In this video, I'll solve this question. I'm going to set up the partial fraction decomposition for this huge integral. I would never ask you to actually integrate this because there'll be so many parts. Just solving for the constant is going to be a nightmare. But this is a good question because it tells you to set up, but doesn't tell you to integrate. So you stop once you have the partial blocks as you like them, but you never solve for any of the constants. Alright, so the first thing I need to do is I need to take the denominator here, that q of x, and see how it factors. Alright, so for the first one I have a cubic. That looks like probably factored by grouping would work, so let's try that. I'm going to factor x squared out of the first part. I'm left with x minus 3. I'm going to take 2 out. I'm left with x minus 3 as well, so that part is x squared plus 2, x minus 3. And x squared plus 2 is irreducible since its discriminant is b squared. 0 minus 4 times 1 times 2 is minus 8, which is less than 0. Alright, so that part's done. I've completely factored the cubic. Now I have to factor both quadratics. 3 and 5 look right for this one. One of them will be a minus, one will be a plus. To get plus 2, I'm going to put plus here. And then for this one, one and 10 don't work, 2 and 5 doesn't. Looks a bit like this might not factor, so let me check over here. B squared minus 4ac, b squared will be 9 minus 4 times 1 times 10 is also that's 40, so minus 31, which is 0, less than 0, so x squared plus 3x plus 10 is irreducible. So that one cannot be factored. Now I'm going to put the two, actually, let me just put all the terms here. Then I'll group the terms that are the same. And so that means that q of x factors completely as x squared plus 2. Then I have 2x minus 3. I have to put them together and consider this a method 2 part. And then I'll have x plus 5, and I'll have x squared plus 3x plus 10. Alright, so the partial fraction is going to have one term for x squared plus 2. For x minus 3, I have x minus 3 twice. That means I'm going to need two separate terms for x minus 3. And remember that each time you increase the degree by 1 until you reach 2. So I'll have x minus 3 to the 1, x minus 3 squared. This one's alone, so I need a single term. This one's alone as well. Now I need to figure out what happens to the top. Remember, if the factor is linear, you just put a constant, that's good enough. If the factor is quadratic, you need to put a linear term, so something like ax plus b. In this case, I have quadratic, so I need a linear on top. All of these, the factor, even though this is to the power 2, the factor is x minus 3, that's what counts. So this and this will just need a constant. This will only need the constant. This one, again, is an irreducible quadratic, so here I'll need fx plus g. When you're asked a question like this, set up. Do not solve for the constants. Do not integrate. Right? You'll waste tons and tons of time. There are too many constants. This would be a pain to figure out what A, B, C, D, E, F, and G would be. We would never ask you to do this.